to the mean, or it's the difference. So we'll do subtraction to figure this out. The difference between a data value and the mean. Okay, so data value, I'll give you like a teeny little equation. So data value we could represent with x, and the mean, if you guys remember the notation we talked about from that, it's got a x with like a little line segment over it. It's called x bar, but literally a deviation would be the data value minus the mean. That would be how you would calculate a deviation. You got to find the mean of the data set, take the data value, see how far away it is from the mean, and that's going to be your deviation. Now, if you look down at this lovely formula that is in the problem, or the definition underneath this definition of standard deviation and variance. X bar, the mean, we've talked about that. Data sample with n data items. So this is just the number of data items. The variance is represented with this lovely little kind of fancy looking lowercase o with a squared. It's a Greek letter. Really, you don't need to know that except for to look for that symbol when you get to the graphing calculator. But does anybody know what that symbol means? It's a Greek letter. It's right here. Freaks people out, I feel like, every time they see it. Have you guys seen this before? It's called a sigma. Do you know what it stands for? Find the sum. That's all it means, sum. Okay, so sigma is for, well, it's a Greek letter if you have, somebody in a frat or a sorority or something like that. But what it means mathematically is to find the sum. So what this little thing says is find the sum of all the deviations and they're squared. And I'm going to explain that to you in a second, but that's what it means, sum of the squared deviations. And then you just divide by the number of data values. So when you find the variance, really it's just an average of the deviations squared. Now, the variance is the square of the standard deviation. Square of the standard deviation. So we calculate the variance first, then you take the square root of that. That gives you the standard deviation. So it says the standard deviation is the blank. It's the square root of the variance. All right, now, most of the time in a data set, they're not going to talk to you about the variance. They're going to talk to you about the standard deviation, but you have to get the variance to find the standard deviation. So that's why I'm going to tell you about that today. But basically, when you have a data set, the bigger the standard deviation or the variance is, the more spread out the data. If you have a really small standard deviation, that means all the data values will be close to the mean. If you have a really big standard deviation, that means that all your data values are going to be spread out really far from the mean. Okay, now, just for technical purposes, we're going to calculate population standard deviation, but there's another type of standard deviation that you guys will see in the calculator. So this says there's two methods to calculate. The first one is sample standard deviation, and the second one is population. So what we're going to work with, I'm going to give you the entire population that we're going to calculate the standard deviation for. A sample would be used if we had a huge data set and we just took a sample of the data to figure out the standard deviation, and not all the data, but we're going to use all the data. This sample, like if you guys, let me just grab a different color real quick. In the calculator, you'll see this. It'll be a capital S with a sub X. The population is going to be like that fancy little O that I have up here with an X next to it. And that's actually the one that we are going to use, okay? Now, the difference is if you have a large data set and you use a sample, in those lovely formulas I just have up here for you, the difference is they put n minus 1 in the denominator And for the population, which is the formula you've got up there above, you just use the number of data values because you know exactly the number of data values for what we're going to use. So just what I want you to remember, we're going to use population. So when we calculate this in the calculator, we're going to use that symbol is what you're going to look for. All right, and I'm not gonna have you guys calculate the standard deviation and variance by hand for any of these data sets because we have the whole population of data. All right, so here's what I have here. I have two lovely data sets, and they are heights of people on two different basketball teams. There are 10 people on each team, and we are gonna calculate the standard deviation and variance. So before we start, let me just have you look. Remember I said the value that's going to have the larger standard deviation, the data is going to be more spread out. So which one of these two teams do you think is going to have a bigger standard deviation? The Pacers, because they're more spread out. Can you guys kind of see that? So we're just going to work through this, and I'm going to show you guys how to calculate these. First thing let me just write down like what these heights are. This is called a dot plot. So each one of the dots represents a person and then how tall they are in inches. So I'm just gonna write these down real quick. So like on the Pacers, I've got one person, their height is 70 inches. Then we got two people at 71. I've got somebody, oh, these little tick marks are kind of hard to see, sorry. Let's see, 1, 2, 3, bless you, one person at 73, one person at 74, one person at 75, and then I've got, let's see, one person at 78, two people at 79, and one person at 80. Okay, so just from there, let me just add these up real quick. I've got, bless you, I've got 10 values, so let me find the average here, because if you're going to find a deviation, you have to know the mean. And I'm going to divide that by 10. I could have probably done that in my head. All right, so my mean for the Pacers here, the mean height, is going to be 75 inches. Okay, let me switch over to the Lakers real quick, and I'm just going to write their heights down and find their mean too. You've got one person that's 70 inches. You have one person at 74, and then we have a ton of dots on the 75. So we've got 1, 2, 3, 4, 5, 6 different people that have a height of 75 for the Lakers there. One person at 76 and one person at 80. So I'm just kind of transferring the dot plot into writing some numbers out. So let me find their average also. So we're just going to take these guys and add them up and divide by 10 because you got 10 people. Okay, make sure I type that 6 times. I totally did. All right, plus 76 plus 80. And ooh, I actually got 750 again, so that means these guys are going to have the same average. Okay, so by hand, what we're going to do here real quick is calculate the variance first, and then we'll do the standard deviation. You don't have to put these in order from least to greatest or anything like that, but we just kind of did, so maybe I'll go ahead and stick with that. Okay, now I'm going to zoom out so you can kind of see the data. I hope I'm not writing too small here. All right, to calculate a deviation, I'm just going to write DEV. All you're going to do is you're going to take the height and you're going to subtract the mean for each of these players. So, and we can do them in any order. I'm just going to go from left to right here. So the first player was 70 inches. The mean is 75. So the deviation there would be -5. And some of these deviations are positive, some of them are negative. That's why we're going to square them. All right, so for each one, I'm just subtracting the mean from the data value. I'm going to see if I can fit these all on here if I write small enough. So every single one, I'm just writing their height, and every single person I'm subtracting 75 from their height. And I just might be able to squeeze this on here. So some of these are negative, some of them are positive. It's possible that you don't have a deviation. Like I had a person in this list that was 75 inches tall, so their deviation would be 0 because they're actually on the mean. But if you have a negative, don't worry. It's just showing you, basically, if I'm 70 inches tall, I'm 5 inches shorter than the mean. If I'm 71 inches tall, I'm 4 inches shorter than the mean. That's all it indicates. Let's see, this one's going to be, then we get positive, I get 3. That means they're 3 inches taller than the mean. I get 4, and I get 5. If it's positive, it just means it's above the mean. All right, now, to calculate the variance and standard deviation, we're just going to really do this. It's going to take one step. What you have to do is you have to take the deviation and you square it. Now, the reason we're doing that, when you square it, it's going to cancel out the negative, because every time I square something, the negative would get canceled out, and as I'm multiplying a negative times a negative. So that's why you square the deviation. So negative 5 squared would just be 25. Negative 4 squared, we'd have 16. Negative 4 squared again, 16. Negative 2 squared would be 4. Don't write 2 for this. Negative 1 squared would be 2. Oh, and I just said that and I wrote it. Would be 1. Would be 1. That is a 1. 0 squared is just going to be 0. 3 squared is 9. 4 squared is 16. 4 squared is 16. And 5 squared is 25. Okay, now all I'm going to do here, you're going to find the sum, and we're going to divide by 10. So we're doing the average of the squared deviations. That's all I'm doing there. So we're just going to take these guys, add them up. So I got 25, 16, 16, 4, 1, 0, 9, 16, 16, 25. Just added all those up, and I got 128. All right, so we get 128, and we're going to divide that by 10 because we have 10 data values there where we calculated the deviation. So this is going to be the variance. All right, so I'm going to write that little O symbol. This is squared. Is going to be 12.8. And then the standard deviation, all we're going to do is take the square root of that number. And again, unless it's a perfect square, it's not going to be a nice number. So just in any of these questions, if it doesn't tell you already, I'm just going to round to the nearest hundredth. So just 2 decimal places. So you don't have to put it in radical form or anything like that. So this is going to give me about 11.31, let's say. That's going to be my standard deviation. Is anybody having a question? Okay. Let me see if you guys can do this. Just go ahead and do the same process. Let me blow it up so you can actually see it. But you're going to do it for the Lakers. So you're going to find each one of the deviations. I'm going to write these numbers down here. So the first person is 70. Their mean is also 75. So we're just going to go through here for each person. And I'm going to try to remember to write 75 6 times. And just each time subtract 75. For the Lakers, a lot of these end up being 0. So this is my deviation here. Your deviation squared. Forgive. Now, hopefully you guys said that if you add all the deviations up, almost six of the 10 are 0 because the mean and the data value were the same, so you don't have a deviation there, but we do have a few data values with a deviation. You should get 52, and you still divide that by 10 data values. So then here, your variance, this is that little kind of cool looking O squared. This should be 5.2. And then your standard deviation is just going to be the square root of the variance. So I'm just doing square root of 5.2 on my calculator here. So then there's their standard deviation here is 2.28, yeah.
Why on the other one did you use 128 instead of 12?
Oh, I'm an idiot. No one stopped me. I'm an idiot. Okay, hold on. Let me fix that. Okay, hold on. Sorry. 12.8. I said it, and then I did 128 here. Forgive. This one, you guys, this should have been, sorry, 3.58. I forgot the decimal place. Forgot the decimal place. All right, my fault. 12.8 was what I should have had under my square root. All right, so your variance is the sum of the deviations divided by how many values you have, and then to get the standard deviation, you just take the square root of that. Don't forget your decimal like I did. Okay, is anybody having a question? All right, so I'm going to memorize those real quick because I'm going to use them on the back. All right, so the Pacers and the Lakers both had, I'm going to continue this on the back, but we're not going to see the data because obviously it's on the front. All right, the Pacers and the Lakers, they had the same average height, which was 75 inches. Now, the Pacers' standard deviation, if I had done it correctly, was 3.58, and the Lakers was 2.28. Now, this question says the heights of all the Pacers fall within how many standard deviations of the mean, and then it asks you the same question for the Lakers. Okay, this is not hard to do, but let me just show you a little process here real quick. The Pacers, the minimum height on the Pacers team was 70. Hang on, let me look back here real quick. I just need the min and max, and actually it's the same for both. All right, so maximum was 80. That was the same for the Lakers. So it's saying, how many standard deviations do I have to go out to cover all the people's heights? So I need to know the minimum and maximum for that. So I need to go from the mean, figure out how many standard deviations away, the minimum and the maximum. That'll cover all the data values. So what you're going to do is you're going to put the mean, and you don't have to draw a visual of this, but I think it helps me. So I'm going to put the mean value in the middle. To go out one standard deviation, so one standard deviation from the mean, you take your standard deviation, which for the Pacers and Lakers, it's a little different. So for the Pacers, it's 3.58. And what you are going to do is from 75, you're going to add 3.58. So we'll get, let me grab a different color here. So we'll get 78.58. And then on the other side there, I'm going to take 75 minus 3.58. And this is going to give you 71.42. All right, now between those two values, you are within one standard deviation of the mean. You have to add it on the upper end and subtract it on the lower end. Does that cover all the heights of the people on the team? Between those two values? No, I got to get down to 70 and up to 80. So I'm just shy of that, but so we have to repeat that process. So all you do, the same thing, just from where you were at, I'm going to add 3.58 on the right side, and I'm going to subtract 3.58 on the left side. So we're going to have to at least go out one more. So if I do that 71.42 minus 3.58, that puts me at 67.84. So we should be good on this end. Let me see if that's tall enough on the other end. So 78.58 plus 3.58. On this end, you would be at 82.16. My marker's dying. All right, so once I've done that process, I'm within 2 standard deviations of the mean. So it says within how many standard deviations did I have to go to cover all the pacers? The answer here would just be 2. And you don't have to draw that out or anything. It just helps me visually to kind of look at it. Now, like we said before we even started, the Lakers have a smaller standard deviation. Their heights were not spread out. They were all kind of concentrated at 75 for the most part. So we'll see if this holds true, if it's 2 standard deviations or it might have to be farther. But you want to do the same thing. Their average was also 75. But if I'm going to go out 1 standard deviation here, their standard deviation was 2.28. So I'm going to add 2.28 and subtract it from 75. All right, so on the left side, you'd be at 72.72. And on the right side, I'd be at 77.28. So between those two guys, I would be within 1 standard deviation of the mean. So not far enough out. I need to go all the way down to 70 and all the way up to 80. So I'm just going to repeat the process. Just on the right side, you add the 2.28. On the left side, you subtract the 2.28. So on this end, you're at 79.56. And on this one, you are at 70.44. So if you guys look at those two numbers, I'm still not tall enough or short enough. So I need to go out another standard deviation to be able to cover this. So I just need to repeat that process one more time. So I'm going to add the 2.28 and subtract it on the other end. Let's see. On this end, you'll be, sorry, I'm getting too close to where I wrote my maximum and mid. 68.16. On the upper end, we are at 81.84. So the shortest person was 70 inches, so they're going to get covered on this lower end. And the tallest person was 80 inches, so will be covered on this upper end. So that's within 3 standard deviations of the mean. So that would be my answer for that question. They're within 3. Is anybody having a question? Okay, let me show you guys then how to do this on the calculator, which will be so much faster. Okay, so it says professional football team scored, and it gives you the scores for 13 games. Find the mean and standard deviation using your graphing calculator. Okay, this will be so much faster than what we just did. And you don't need the data values in order from least to greatest or anything like that. So I'm just going to go ahead. It's very similar to what we did to input the data for finding mean, median, mode. We're the same thing. I'm going to hit stat, and we're going to edit. And if you guys have anything in here, you can just arrow up to the top, hit clear, and hit enter, and that'll wipe out anything in the column. Does anybody's not start with list 1 in that stat menu? Okay, just let me show you this just real quick if I didn't yesterday. If you accidentally delete a column or something, just hit stat, and then that number 5 setup editor's a reset for the stat menu. Just hit enter twice, and then if you go back in, it should restore anything if you accidentally deleted something. So I'm going to put in those football scores. So I'm just looking down the list. Doesn't matter the order. You do have to put in the enter. You have to hit enter in between each one. There should be 13 of them. And I'm just going to go back and check and make sure I didn't mistype anything real quick. Okay. So we're just doing stat, and then you're just going to hit enter to edit this. And then in list 1, you want to type your data. Once you've got that gone, then you're just going to hit stat again. Now, once you got the data in, you're going to calculate. So you're going to arrow over here to the menu that says calc. And we still actually want the same thing where we got mean, median, and mode. You want the one variable stats. So on that first menu, once you get to the calc menu, you don't have to move or anything, just hit enter. And then just keep hitting enter until it shows up. It does ask you to do, let's see, the mean. So the mean would be the 21 point, let's say, 31. And then what you're looking for, the standard deviation. So we don't want sample standard deviation because we have the scores for all their games. So you want the population standard deviation, which is going to be like that little weird OX there. You don't have to take the square root. It doesn't display the variance in the screen here. So you have to get the variance. If you do this by hand, if you use the calculator, you can just have the standard deviation right there from the screen. So this would be 10.45. So we don't need to take a square root. I'm just going to go 2 decimal places here. Okay. Does anybody think, if they're looking at that lovely list, that they could tell me the outlier? What do you think? Yeah, for sure. All right, so the 52 is going to be the outlier. And so what I'm going to do, this question says find the outlier. We're just going to remove it. All right, so to do that, sorry, I should have this on screen. You just hit stat, and I'm going to go back into the edit menu, just hit enter, and just go down. The 52 is, sorry, it's at the very bottom, and I'm just going to use the delete key, and I'm going to get rid of that. Delete key is right above the stat button, and then I'm going to go back in and recalculate the data. We just talked about the mean and the standard deviation if we remove that outlier. So stat calc, that one variable stats, just keep hitting enter till it shows up. Now, my mean, 18.75, and my standard deviation, again, I'm just going to go 2 decimal places, 5.78. So then the question underneath here just says, how does removing the outlier affect the mean and the standard deviation? If you guys look at that, that is drastically different for the standard deviation. It's almost cut in half. So removing the outlier, obviously in this case, lowers the mean and the standard deviation. Lowers both. And I would tell you, once you remove the outlier, this information in part B, this is going to be more accurate to describe your data. Whenever you remove an outlier, it makes the rest of the data make more sense. It's more accurate to describe your data. So is anybody having a question? But you can see just removing that one value totally changed what we had for the mean and the standard deviation. Okay, I'm going to do one more quick example. We're going to do this one on the calculator too. All right, so this says Babe and Hank are professional baseball players. Their home runs, I'm pretty sure that's not supposed to be one word, per season are recorded for 8 seasons. Who is the better hitter and who is the more consistent hitter? These are the 2 questions. Okay, how would I figure out, if there's my data, what would you use to figure out who was better? Who was the better hitter? What do you think? Yes, okay. This would be who has the better average, right? Who has the better mean? That's what I would find to answer that question. Okay, what data value do you think would you use to determine who was more consistent? What could I pick out of that statistics information that we've talked about so far that would tell me the person is more consistent? Go ahead. Yes, this is more consistent. This is going to be the lower standard deviation. Okay, so for more consistency, the smaller standard deviation in general. Now, in terms of what I mean by the better mean or the better average, that depends on what you're talking about. In this case, this would be a higher mean, but like if we were talking about like bowling, or if we were talking about golf or something like that, a lower score is better. So the better mean, you got to think about the context for what that is. So here's what I'm gonna do, and I'm gonna show you guys real quick. Just put these in. It doesn't matter which one goes first. I'm gonna go to Stat, Edit, and I'm just gonna clear out the first list, and I'm just gonna type that first row, and I'm just gonna grab the mean and the standard deviation from this data set. So there's 8 games, gives you their home run, or 8 seasons, excuse me, gives you how many home runs they had for the season. Once you got that in, just to practice, just hit Stat Calc 1 variable stats. And I'm gonna write down the mean and the standard deviation. So the mean, 37, standard deviation is about 16.35. Again, just a lot of times these are kind of nasty decimals, so just round to 2 decimal places. Then I'm just going to go back in, Stat, Edit, get rid of this data, just arrow up to the top, hit Clear, hit Enter, and then we're going to type in the other person's. And I like to just take a second and look and make sure I didn't type anything wrong. Go back, once you got that in, Stat, Calc, that statistics menu, just keep hitting Enter till it shows up. The second guy, now his average, 30 point, I'll just go ahead and write it out, 625, standard deviation here, 13.06-ish. Okay, so which person in general is going to be the better hitter? It's going to be the person who has the higher average. So that's going to be, in this case, Babe. And then the person that's more consistent is not going to have their data as spread out. Both of these people have kind of a huge standard deviation going on here. But this one's 16.36, this one's at 13. So the lower standard deviation is going to be the person who is more consistent. Is anybody having a question? Okay, I talked for a